So we're going to continue on solve systems with graphing. We're going to do some application problems today. And we're also going to learn what we call the check. So we talked about the fact that there are 3 different ways to solve a system. Graphing, substitution, and elimination. We learned graphing yesterday. And algebraically, yes, that's what we're going to talk about next. Algebraically is not how you solve it, but it's a way to check. So if I were to bring you back to a problem like this in chapter 5 or unit 5 or whatever we did, and I said, hey, if I graph this linear equation on a coordinate plane, would this point be on that line? And you had 2 options. Physically get a piece of graph paper out, graph that, and see if 0, 7 is on the line. But what was the other option? Just plug in your x and your y and see if it's true. This one, actually, I could use a shortcut. Does anybody know for sure that this is a no? You know how I know for sure it's a no? Because 0, 7, when x is 0, the y is your y-intercept. So they're telling me my y-intercept would be 0, 7. But according to my equation, it's actually what? 15. So let me just show you that when I put in 7 for x, and I'm checking, and 0 for y, I'm sorry, 7 for y, and 0 for x backwards. Does 7 equal 0 plus 15? Does 7 equal 15? No. And that's how I know that 0.07 is not a solution and on that line. So guess what we're going to do with the check? For the next 3 tests you take, you are going to be able to check every one of your answers and make sure the answer you're putting is correct. Here's how you're going to do it. I want you to think about this. If I have 2 lines, let's say I have this line here, and I have this point that's on that line. I checked it, it matches up, it equaled each other, and then when I have this other line, that same point is also on that line. So what do you think that means in terms of my check? It means if I have 2 equations, for example, x plus 2y equals 7, and 3x minus 2y equals 5, and I just did some fancy stuff, and I think, based on what I just did on my graph or whatever, that is the solution to where these 2 lines meet. That's what I put on my paper as my answer, so I hope I'm right. Before you turn your paper in, you could see if you really are right by doing this. If I plug 3, 2 in here and get true, then I know it's on that line. If I plug 3, 2 in here and get true, then I know it's on that line too. And the only way for it to be on both lines is if it's that point. So that would be a yes. Watch. If I plug 3, 2 in here and get a yes, then I have to check here. If I plug 3, 2 here and get a no, it's not true. Is it the point where they meet? No. That would be like, it's this point, meaning it's on this line, but it ain't on this one. If I plug 3, 2 in the first one and get a false, do I even need to check the second line? No. So what was all that conversation about? In order for me to confirm that yes, this point is the solution to this system, you gotta plug it in both equations and get a true for both, okay? So what do I mean by that? I mean, if x is 3 and y is 2, I need to see if this equals 7, and it does. Here's what this is gonna look like in your worked out answer key. It's going to say 7 equals 7. That is a yes. Then they're going to put a little check mark under it. Then that means that they have to check the second one, because if it's on this one also, 9 minus 4, does that equal 5? Yes. 5 equals 5. That is also a check. And when you have 2 checks, yup, 3, 2 is the solution to that system. Does that make sense? It's kind of common sense, right? If this 7 was an 8 instead of a 7, would I even need to check the second equation? No. So do you understand the check? That's what we're going to call it. So it's not really another method to solve it. I guess you could solve it. Like, you'd be here all day, though. If I just was given this, I would go, I think those are going to meet at 1, 2. Nope, that didn't work. Let's try 1, 3. No, whoa, that would not be the best way to solve this. So this is more of a check instead of a solve. Okay, are you good with that? All right, awesome. Moving on to application problem 1, and there's only 2 different types. And I know you're going to get both of them, okay? So let's take a look at application problem number 1. Let's say that you're going to go to the Kennedy Pool. Does anybody go swimming at Trenton this summer? Okay, or usually go there? When you go, there's 2 options of ways to pay. So option number 1 is season pass holder. So let's say you are a season pass holder, and that's going to cost you a one-time $90 fee. But every time you go, it's only going to cost you $4 per visit, which isn't too bad. $90. So Deborah, you're good up here? Pay attention, please. So option number 1 is pay $90, but then every time you go, you only pay $4. Okay, will somebody grab that door, please? Option number 2 is, hey, I'm a 13-year-old kid. I don't have $90 laying around, so I can't buy a season pass. Well, then the only option you have is to pay $13 per visit. Okay? So in application problem 1 for systems, that's all the information you get. And technically, you have everything you need to create. It's going to say, write a system of equations to represent your options. I know that you know how to, like, as soon as I said that, you were probably writing the equation in your head, weren't you? Okay, whether you're using C for cost and B for visit or X and Y, you probably went C equals 4V plus 90. I am confident by April 11th or whatever today's date is that all of you are good doing that, 12th. Okay, you might have said, well, I don't know, man. If I got to pay 90 first, I'm going to put 90 first, and then after that, I pay 4 per visit. Fine. Some of you might say, C and V is so confusing to me. I'm just going to put Y equals 4X plus 90. Fine. Or Y equals 90 plus 4X. I don't care. All of those are fine with me. C and V are helpful when you're dealing with word problems because when you got to go plug things back in later, okay? So then what would that mean my equation is for my option 2? No season pass. It's just what?
C equals 13x.
Yeah, C equals 13x. You did a little combination. Use some C's and some X's. So the cost is going to equal 13 per visit. There's no number after here because I'm not paying them $90. Okay? So what system of equations would I write? I would basically just take both of these and write them one above the other, and there's my answer. So part of this application problem is going to be me just giving you information, and then I think that was what was on the PSAT, wasn't it? They just said this. They just said, hey, I just basically summed up this whole scenario here, and your answer was A, B, C, or D. So you know it's got to be what? C, right? And then sometimes that's all you have to do. You're done. But not in here, right? So now that you have your system of equations, you're going to use that to answer a whole bunch of questions. So let's say you look at your schedule and it is packed. You have a tournament almost every weekend. You have a vacation with your friend in Florida. You have all these things planned. You only have 5 free weekends to go to Trenton Pool. What option should you choose if you can only visit 5 times? Hi. Yep, no problem. Bye. Shane, office. Okay, they need you in the office real quick. So if I'm only going to visit this pool 5 times, I think you probably can figure out with a quick little mental math, what's your better bet? Option 2 is more economical. Okay, let me show you why. I'm going to take V and plug it into each of the equations and see which has a lower C. So what would my cost be for 4 visits plus that whopping $90 season pass? Yeah, it's going to be $110. I'm 13. I don't have $110. If I go 5 times at $13, still going to cost me $104. But isn't it cheaper than 100? I'm sorry, 65. That's my next problem. You're like, it's still a lot. 65 is still a lot cheaper. So at 5 visits, option 2 is your best bet. Let's say you wanted to go 8 times. Is option 2 still your best bet? I don't know. Let's find out. So this time I'm going to do 8 visits. My cost at 8 visits is $122. And this is where I got my 104 from. Still cheaper. Now, let's figure this out. If I want to know at what number of visits will it not matter which option I choose? Meaning, what would the number of visits need to be where it's going to cost me the same? So what would I do? You could keep playing guess and check, but you don't have time for guess and check. Actually, you don't need guess and check when you have algebra. So watch what you're going to do. The question I'm asking you now is, what number of visits would the cost be the same? Hey, in math, what's another word for same? Equal. Hey, we got a symbol for that word. And now I go back up to the system of equations that I wrote. I kind of don't need the C. And what do I do with these two expressions? I set them equal to each other. Watch and listen. Hey, at what number of visits will $4 per visit plus 90 equal 13 per visit? And now I have a 2-step equation that I have to get some combining like terms on. I think there are people who are confused on what to do here. So you know how when you play checkers, you dump the box out before you can play, you have to sort. I'm red, I'm going to take all the red checkers. You're going to be black, you take all the black checkers. I got to sort. If it's got a V, I want it on one side. If it doesn't, I want it on the other. So my best bet here is to subtract 4V from both sides. Get 90 equaling 9V, divide by 9, and what do I get? 10 equals V. What does that tell me? At 10 visits, it doesn't matter which option you went with. How much is it going to cost at 10 visits? You can do a quick $130. Put 10 there. 40 plus 90. So when I put 10 in for both of these expressions, it's $130. So if this is visits, comma, cost, what ordered pair did I just discover? 10, comma, 130. Hey, so you mean that 10, comma, 130 is the solution to this? Do you see how that tied into it as a word problem? I'm going to take it one step further and show you what it would look like on a graph. If I took a graph like this, okay, I only need quadrant 1. And if I said that this is 2, 4, 6, 8, 10, actually let's just do it this way. This club right here, I don't know if this is 90, but we're just saying it's 90. Option 1 is going to cost me $90, but this slope isn't going to be as steep because it's only $4 a visit. Okay, I got to see if I can do this right. 2, 4, 6, 8, 10. This is 10. I'm going to start down here for my option 2. I don't have $90, but it's going to be a lot steeper because, it should be straight, because it's $13 a visit. What happens right here? It doesn't work out perfectly, but that is 0.10, comma, 130. I want you to just watch this. At what point, look at option 2 is cheaper, option 2 is cheaper, 1 visit, 2 visit, 3 visits, 10 visits, boom. They're both 130. That should be 110 then. But after I keep going, what's happening? Option 2 is more expensive. Option 1. That's when that $9 season pass investment starts paying off after 10 visits. At 10 visits, it doesn't matter. And before 10 visits, option 2 is cheaper. Do you understand? So this is what word problem for option 1 or for problem 1 looks like, okay? Take a look at this one here. Cover this up. I know you saw D already, but that's okay. That's okay because I want you to actually come up with these. The cost to join an art museum is $60. If you're a member, you can take lessons for $2 each. If you're not a member, then it costs you $6 each. So it's more for non-members. At what number of visits would it be beneficial to be a member and have paid that? So can you come up with 2 equations? What would the first equation be? Y equals what? 2x plus 60, right? Membership fee, cost per lesson. I don't want to be a member. I don't have $60. Oh, well then you better be prepared to pay $6 a lesson. Good? So if I just wanted to know, obviously it's D because it's that. So if this was a question, would you be able to find that system? And then would you even be able to solve it if you needed to using a graph? Yes. And if you even had a graph just to kind of estimate, could you then use the algebraic solution to check and see if your estimate was right? You see where this is going? Very good. Okay, that is word problem number 1. Okay? All right, application problem number 2 looks like this. You're going to recognize these. All right. So let's say in addition to swimming at the Trenton Pool this summer, you also want to get a job. So you're going to get a job at a Metro Park where you can rent things, right? So you're the kid behind the rental counter. And you can rent bikes. People can rent bikes from you, or people can rent rollerblades from you, okay? And your boss wanted you to keep track of the rentals, and you kept track that one day there were 25 rentals, and he comes in and says, oh, great, we rented 25 items today. Hey, how many of those were bikes? And how many of those were skates? And you went, oh, shoot, I didn't know you wanted me to keep track of what were bikes, and I just had 25 total. And then your boss says, don't worry about it. How much money did you bring in today from those 25 rentals? And you count it, and it's $450. And he goes, okay, we can use algebra, okay, right, to figure out how many were bikes. And like any boss would actually do that, right? I'm gonna like stalk your bosses one day and like trick them into making you do this. So let's take a look. All that information that I just gave you was here. Skates were 15, bikes were this. You collected. So I want you to write that information down right now. Here's what you're gonna look at. You're gonna look at where are we at? So skates are 15. Bikes are 30. Okay? That's the information that you're given there. And then we need a totals column. Our totals were 25 rentals. And our total money was $450. You have everything you need to write a system of equations. Yeah.
Is it ever possible to get multiple combinations?
Yes. Yes. Sometimes it could. Yeah. Well, it depends. It depends on if it's the that's 7-5. Sometimes we get into special combinations. Yeah. Yes. James. So watch. He's trying to figure out how we're gonna do this. We have to set up a system of equations, right? Okay? So to get these two equations, I'm going to walk you through how to do it. To walk you through how to do this, equation number 1 is going to be an equation made up of the number of things. In this case, it's rentals. Next problem, it might be books, and the next one, it might be hours. In this case, this equation is going to be my number of rentals. Equation number 2 is going to be involving money. Okay? So, up here, I have to figure out what I'm going to let x equal and what I'm going to let y equal. This is really important over here. Usually what they do in the book is whichever one they said first, like skates is listed before bikes, we're going to let x equal the number of skate rentals, and we're going to let y equal the number of bike rentals. That's important. That's really important. Okay, so when I go to set my equations up, it's not how you think. It's not standard, or it's not slope intercept form, right? Because you know right off the bat, they're not talking about it starts at this much and goes up this much. It's a whole different type of problem. So, how many rentals did I have total? 25. How much money did I collect total? Do you remember what an equation looks like in standard form? It's the x and the y on one side and then the constant on the other. So guess what? If x represents skates and y represents bikes, what do I need to add together to get 25? X plus y, right? You're telling me the number of skate rentals, which I don't know, by the way, plus the number of bike rentals, which I don't know either, but I do know together they equal 25. My first equation is written. My second equation is when I factor in that 15 and that 30. Take a wild guess at what you think that equation should be. 15 for every, I collected $15 for every skate rental, which is why I would multiply that times x. And I'm going to add that to 30 per every bike rental. And that is how you get that solution going, okay? So now that you have your system of equations, you have your x plus y equals 25, you have your 15x plus 30y equals 450. This one's a little bit trickier with what I ask you to do with it because you got to have some pretty detailed math or some pretty detailed graphs to go with this. So option 1, if I need to graph these two, I have two options. Put it in slope-intercept form and graph it, right? Is that what you would think of? Okay, so were you just subtracting what, x from this side? So when you subtracted x from this side, you got y is equal to negative x plus 25, right? This one's going to take a little more work, but that's okay. I'm going to subtract 15x from both sides, and that's going to give me 30y. And then I'm going to divide everything by 30. This is stuff you know how to do. Y is equal to negative 1/2 x plus 15. I have these equations. If I had a graph that I already had prepared for you that went up to 25 and the increments were already there, it would be perfect. I don't know how far we're going to go with that yet, but would it look something like this? Here is, let's just use this, 5, 10, 15, 20, 25. And it's hard to go down, but you know, you're going down a half. And then this one is 15, right? But it's going down by 1, so that's even a little bit steeper. And then you could look at that point where they meet, and then, you know, like I said, if I give you some good graph paper, then you should be able to figure that out, okay? Once we get to the next two sections, you'll be able to figure out that. So let me show you what I mean by this. So let's say you have this beautiful graph, and you were able to perfectly graph each of these And it looks like your point is what? 5, 10, 15, 20, comma, 5. Because each grid's going by 5. So it looks like your point is 20, comma, 5. So you could just take a wild guess. And 20, comma, 5, by the way, what does that mean? 20 comma 5 means what? What's the x? That's why that's important. And what's the y? So you're telling me that 20 pairs of skates were rented, but only 5 bikes were rented? So if I'm like the owner of this rental company, I might be looking going, skates are like quadrupled the amount of in demand as bikes are. I'm gonna hook up with some new skates. Or maybe I need to get better bikes. That's why people don't want to rent them. Okay? How can I make sure that I'm right? I plug it in, get a yes. Plug it in, get a yes. So obviously, what's 20 plus 5? 25. So it's a yes for the first one. What's 20 times 15? 2 times 15 is 30. Add a 0. What's 5 times 30? 150. And what's 150 plus 300? Yep. So 450 equals 450. So yes, 20 pairs of skates, 5 bikes. Okay? All right. Let's take a look at this example. Your school is selling football tickets for a home game. The school sold 35 tickets on the first day, and from those 35 tickets, they collected $86. Student tickets were $2 each. Non-student tickets were $3 each. Right now, I don't need you to even take it to this point. I don't need you to find that there were 19 student tickets and 16 non. Can you just set the system up? What 2 equations would you set up? Try that right now. So what 2 equations could you set up that will eventually help you figure out? Look back at the notes that we just took if you need to. So if you let X represent students and Y non-students, all I know is the number of student tickets were X, non-student tickets were Y, and I sold a total of 35. Good. So are you catching on that your first equation is always going to be X plus Y? Okay. And then you incorporate that money aspect to it. Student tickets sell for $2 a piece. Add that to the fact that you sold some non-student tickets at $3 a piece, and those amounts equaled 86. And right now, I just care about you being able to set it up. When we get to substitution and elimination, we'll figure out how many of each tickets there were, okay? All right, I realize I forgot to show you one thing in application problem number 1. So I want you to go back to this part. Sorry, where it says what number of visits would they equal the same? So 10 visits would equal, right? So sorry, shift your brain here a minute. What if your parent said to you at the beginning of the summer, I'm going to give you $135, and you can spend it on whatever summer activities you want. And you are like, I'm going to Kennedy Pool, I want to get better, I want to learn to swim. So you're going to put all of it there. Instead of knowing what V is, this time you know what C is. So if you're going to put all 135 of your dollars to this pool, which option's going to get you more visits? 1 or 2? And guess what? You don't know until you plug it in. So watch. C equals 4V plus 90. C equals 13V. So if I put 135 in for C and solve, as a kid, you know what you're thinking? Holy crap, my parents just gave me $135 and I got to hand 90 of it over right at the first day of summer. So now all I have is $45 and it's $4 a visit. I'm going to be able to go about 11 times. Because that's really 0.25. Can you go 0.2 of a time? No. So how many visits you going to get if you go with option 1? 11. If I divide this by 13, look what pops up on my calculator. 10.38. Can I go 0.3 of a visits? So how many visits can I really go with option 2?